Hello students, this video is going to go through the process of completing the resistors worksheet. We will have looked at how resistors work in class and also now how to tell the value of a resistor using the color codes. So the resistor worksheet is available on our class page. You should be able to download it. We do have a color chart that we can use on the top of the page here. However, you might also like to use a different color chart or color wheel, depending what you prefer. They should all work the same. Just make sure that what you're looking at is for 4-band resistors in this case. So we'll have a look first at the example, and then I'll go through a few of the questions as well as some additional examples. So the first thing I'm asking you to do is to look at the resistor pictured here and then tell me what the colors are in this first row. So reading from left to right, the first one is brown, then black, then red, and then this is gold. Remembering that there's always a larger gap between the third band and the fourth, being the tolerance. So that's how we know that we're reading it in the right direction. If we tried to read it the other way, we would get some very weird results. So writing those colors in, brown, black, red, and gold. Then we're using our chart to get the values for those colors. So simply what the value is up here. So brown represents 1, black represents 0, red represents the number 2, and in the tolerance section, gold represents 5%. So we just enter those values into our table. The third line down asks us to find the supposed value, the perfect ohms value. So we do that by simply taking the first band value as the first position number, the second band value as the second band number. And now this is the part that sometimes gets tricky. The third band is our multiplier. The easiest way to think of that is how many zeros to add. So the first two numbers are exactly what they are, the 1 and the 0. But this time the number 2 is not a 2 in this spot, it's 2 zeros added. So this becomes 1,000 in total. 1, 0, and 2 additional zeros written on the end. We can then work out our percentage. So we want 5% in this case, because that's what gold is, 5% of 1,000. By all means, use a calculator. But of course, we can also do some simple math here. If we divide by 10 or 10% first, just by taking a 0 off the end, that gives us 100. And we want 5%, not 10, so we half that, and we end up with 50. We can also do that, obviously, with our calculator. Whatever suits you best is fine. We then need to look at simplification. So when our numbers start getting bigger, we don't want to write really large numbers, so we start looking at simplification. Just like we simplify weights and volumes and so forth, we can simplify ohms. So here we have 1,000 ohms, and that is very much like saying 1,000 grams, for example. We turn that into kilograms. So just like that, we do 1,000 ohms turns into 1 kilo ohm, represented with the lowercase k. 1 kilo ohm, 1,000 ohms. And it's still plus or minus 50 ohms. This can't be simplified. It's already a fairly small number. And then finally, we want to work out the overall range, the range of values that if we tested this real resistor would be acceptable to still call it a 1K or 1,000 ohm resistor. So we take our 50 ohm tolerance away from the expected value to end up with our lowest possible, which is 950 ohms. We will then add that 50 to our expected to get the upper value. So anything in this value from 950 up to 1050 would be considered acceptable, and we would consider that resistor to be a 1K resistor. Notice here with this another type of simplification. Instead of writing 1050 or 1K 50 ohms, we can write it like this, 1K 50. It's a shorthand that is commonly used to separate out those parts of numbers. So we've still got 1K and then 50 more. And we'll see that also being used with some other numbers in a moment. So let's scroll down. I'm going to go through these first three with you. So again, if you're doing this worksheet, you can use this if you already had a go as just a way to correct what you've done so far. Obviously, if you're doing this worksheet and you're watching the video first, yes, you could just fill them in, but of course that's not going to help teach you anything. I hope that you are trying to do it first, or even as the video is playing, and checking your answers as you go. Of course, you do have more questions after this to fill in anyway. So let's have a look. First of all, we need to write down our colors. So in the first one, I've got blue, and of course I can't spell already. Then I've got black, then I've got green, and then I've got gold again for our tolerance. If I look up at the table, I'm not going to keep scrolling up. I've got another table next to me here. But if I do look up at this table, then I would see that my blue represents the number 6, black represents the number 0, green represents the number 5, and of course gold also represents 5%. So let's work out the expected ohms. So we take our first value, 6, we take our second value, 0, and then we look at our third one and we say, right, that is 5. So that means over here I put 5 more zeros. 1, 2, 3, 4, 5. Let's look at that number. So that number becomes, there's our thousands, there's our millions. So we've got a 6 million ohm resistor. So what's 5% of 6 million? Well, again, we can do it with the calculator, or we can do some simple math. So if I took 1 0 off, I would have 600,000. Halve that again, in fact, would be 300,000. So my expected value is 6 million, and my tolerance is 3 million. Sorry, 300,000, my apologies. Let's simplify that. So we've already said that's 6 million. So let's do 6, and the abbreviation for million in this case is a capital M. So I like to usually have a little space there, but 6 million ohms. And we can simplify 300,000, you've got it right, 300 K ohms. So that is our abbreviation for 300,000. So what does that create as our range? So we take our 6 million and we take away our 300,000. So that's going to be 5 million, we'll do the M, 700,000. Okay, so that's 6 million taking away 300,000. So 6M 700K, 6,700,000. If we add that, so add our 300,000 to 6 million, we're going to get 6,300,000. So our range is anything from 5,700,000 ohms up to 6,300,000 ohms would be considered an accurate resistor. Let's do another one. Here we have red, followed by red, followed by black, and followed by gold again. So just like before, let's look at those colors in our chart. So red represents 2, 2 again, black 0, and one more time, we've got 5%. Let's bring down our numbers. So the first number is a red, so it's a 2. Second number is a 2. Now here's where it can get a little tricky. Black represents 0. Don't be tricked into putting a 0 here. Remember, the multiplier can be thought as how many zeros. So we want 0 zeros. We want no zeros added on the end. So in fact, we just stay, with 22. So 2, 2, and no more zeros added gives us 22 ohms. So what is the 5% of 22? Well, again, you can work that out, but I've already done that, and I know that it's 1.1 ohms. Okay, let's simplify that. Well, it's already a small number. There's no real simplification, so we just put it straight in. And the same with our tolerance, because there is no simplification to be made. But we can do our range. So 22 minus 1.1 is going to give us 20.9 ohms. And our upper range is going to be 22 plus 1.1, which is 23.1 ohms. So in this case, the trickiness, or the two things maybe the bit tricky, number one, and most importantly, don't get tricked by a black value in band 3. That is 0 zeros added on. Don't add any more. And also when your numbers are small, there is no extra simplification. So don't try and look for one. And the final one I'll do in this video, because we're already come out for 10 minutes, is this third one here. So let's do that again. So we have yellow, violet. If you write purple, it's okay, but the charts usually say violet. Yellow again. Oops, I can't spell. Really can't spell today. Sorry about this. Yellow and gold again for our band. Sorry, for our tolerance. Let's bring in our values. So yellow is equal to 4, violet is 7, 4 again, and our good old 5% for gold. Let's put in the ohms. So again, first value, straight down. Second value, straight down. Third value, remember, is how many zeros? So let's put 4 zeros on the end of this. And that gives us a value of 470,000. So let's work out 5% of 470,000 again. Use your calculator, but it ends up coming out as 23,500. Let's simplify. So 470,000. We know that the simplification for thousands is K. So we're going to get 470 K ohms. 470,000 ohms. 23,500. Well, 23,000. Put the K in. And then you just put the 500. So 23K 500. It's a little bit like what we saw up at the top here when we had millions and thousands. Just put in the character as you say it. So 23,000, there's the K for 1,000, 500 on the end. Let's do our range. So 470,000 minus 23,500. So you can work that out. 470 minus 23.5 would work, or you can go to the expanded version and type the full 470,000 minus 23,500, whichever method helps you get it correct. And again, I suggest you use a calculator, but you end up with 446,000. So I put a K, 500. Okay. So 445,500 ohms is the lowest value. The upper value would be 493,500. So that would be the simplified way to write it. So hopefully after watching those three, plus the original example at the top, you have an understanding of how to read a resistor value and, of course, work out the values that you need and, in the case of this worksheet, fill it in. So if you need to, obviously rewind, watch it again, but hopefully this has helped you out.